Welcome to the video on animated values in TP. This is going to be just a quick look at how we can deal with animated values, make them respond on a per particle basis, and then we'll show how we can set up kind of a more advanced black box that we can reuse at any time so that we don't have to animate parameters on operators. So let's go ahead and start off. We'll just create a top level dynamic set. We'll call this animated values. Oops. And in our first example, so this will be example 1, we're going to go ahead and create a dynamic set where we're going to control the birth of particles. We're going to go ahead and use first just a simple position born example. We're going to set this to use the particle rate. This right now is set to 25 per second. What we're going to do is we're going to overwrite that by controlling the input for rate. We're going to go ahead and use a float value. Connect that float to rate, and so now this rate value coming in is going to supersede and overwrite and completely replace this value. Sometimes with some parameters and some operators, TP used to either act as a multiplier in certain cases, but typically in most cases it will completely override and replace the existing value here shown in the UI. So what we're going to do then is we're going to go ahead and animate this float value, which is as simple as setting, let's go ahead and set this up to say 500, and then by frame 50 we'll die back down to 0. And we're going to turn off auto key because we're going to set the speed value here a little bit higher. And what we'll notice is that let's go ahead and select that float. We'll see this float value is changing as we go, because it's responding to our keyframes. If we go ahead and right click in this field and say show in track view, it's going to show us our float helper right here, and it's got an animated Bezier float curve associated with it. So we can go ahead and make some changes here. Let's just tweak this around a little bit. So this is one of the ways that you can really respond to very artistically driven input. When you want things to happen at a very certain rate or with that much control, you can go ahead and use a curve like this. So we'll shape it just a little bit, and it's going to go ahead and return just about the same result. Births a whole bunch and then fades out. So this is just one very simple way that we can do this with animated values. We're going to disable that example 1, and we'll create example 2 now. And here in example 2, what we're going to look at is a little bit different. We're going to have 2 rules. We're going to create some particles in a birth rule, and then we're going to animated velocity in the next rule. So in order to do this, we're going to use a particle draw because we want to exert some specific control. We're going to go ahead and we'll leave their lifespan at 30, which is fine. So here at frame 0, we'll go ahead and create 1 particle, and then we'll come out again to frame, say 5, create another particle, 10, another particle. And what this is going to do then is it's going to add a particle at each of these frames that we specify. And on frame 20, let's go ahead and we'll add 2 particles just for kicks. And frame 25, and then finally frame 30, we'll add 3 particles. Okay, so we can go ahead and see those be created over time, just like that. What we're going to do then is we're going to control their velocity by animating that velocity parameter. So all particles, we're going to give them some velocity. Connect this. And this velocity speed value, we're going to go ahead and animate that. And we're going to kind of take note of some important things that happen in TP. So say up to frame, now these particles, remember, have a lifespan of 30 frames. So we're going to animate this velocity speed within 30 frames. Say by frame 10, we want your speed to be 100. You can see that we get the little brackets around that spinner showing us that this is an animated value. This is the keyframe of that value. And then by frame 30, we want to go ahead and set your speed back to 0. And turn off auto key. And what we're going to see then is as particles are born, immediately immediately they are assigned whatever the current speed value is. So you can see here when speed is fading off, all of them move very slow, even those ones born at 30. So this is really not the kind of behavior that we typically want with animated value control. We want that speed to be controlled per particle. So what we're going to do is we need to use the particle's age to control what time value we're looking at for this speed parameter. And so what we're going to do is we're going to expose the input for time on this velocity operator. And then we're going to have the particle's age control the time of this velocity. This is pretty interesting because what it's going to do then is as a particle is born, as each particle is born, its age starts off at 0, 1, 2, 3, etc. And so this velocity is going to be doing a unique lookup per particle to check what is my value at this time. So whatever that particle's age is. So whatever speed value is set, or any of the parameters that have been animated, it's going to go ahead and return those animated parameter values based on this time coming in. So now we get a little more expected behavior. The particles, as they're born, they start off slow, they go fast, and then they slow down again. So this tends to be much more what we're looking for. Okay, and so this is one way. However, we usually try to avoid animating parameters on operators just because it can be a little hard to manage when we have a lot of these going on. Not usually a big deal, but there's another way that we can kind of pull this data out and make it a little more modular so we can apply it as needed. What we're going to do for that then is we're going to take a look at creating another example. We'll just call this, we'll duplicate this example 2 dynamic set. Call this one example 3. And here in example 3, what we'll do is we're going to rebuild a black box that we have called GraphOp. Basically means graph operator. We're going to go ahead and delete this velocity operator because it has that animated parameter on it. And we want to go ahead and overwrite that and replace it. What we're going to do though is we're going to expose the speed input for our velocity. And so it's going to go ahead and replace this speed value here. And what we want to do is the same kind of thing. We want to, based on the particle's age, we want to look at an animated curve and kind of use that to control the speed. The way that we're going to do this is with a helper called value to time. Value to time kind of acts as a lookup. Whatever value is coming in, it takes, a range of values. The value 0 or value 1 is the starting value to start to evaluate with, and value 2 will be kind of the top level value, the high point. And what it'll do is, based on these values coming in, is it's going to return a time value kind of interpolated somewhere in between these. So right now, if the value coming in is 0, the time coming out is going to be 0. And if the value coming in is 10, the time coming out is going to be 30. And imagine if the value coming in is 5. So a 5 coming in is going to result in, it's halfway between these values, so the time coming out is going to be halfway between these two, so it'll be 15. So it's just kind of a linear interpolator. But we're going to take a look at how we can actually modify this with a curve, and so that we can get a little more artistic control in there. And of course we do want to be looking at the particle age. So, and our particle age we know is anywhere from 0 to 30. So we're going to go ahead and set our maximum value of 2 to 30. And then here in a little bit we'll take a look at how we can handle just any particle age regardless of a maximum. We're going to turn on the stops. I will explain why here in a minute. And we're going to set the time 2 to be 100. So when the maximum value coming in is 30, the time that comes out, the time value, is going to be 100. And what we're going to do then is we're going to create again a float value. And actually, you know what? Let's go ahead and grab the float value we used in example 1. Let's copy that. And we will paste that in here. And now the float, what we actually want to do is we don't want the value input, we want the time input to be controlled. Because remember here in example 2, when we use the age into the velocity's time, it kind of performs a lookup based on that particle age and looks up a specific time and looks at this animated range here and picks the time at which to evaluate. Boy, that track view closes slowly. Now, if anybody knows how I can make that close faster, please contact me. Okay, so animated values, what we're going to do then is we're going to go ahead and we've got this animated float already. And let's go ahead and get our all in view. But what we want to do is we want to actually set the maximum time. You remember, the maximum time should be 100. So we're just going to go ahead and take this key and set it at 100 there. Go ahead and modify this a little bit. Okay, so got a nice curve. It's going to fade into a peak pretty quick and then do kind of a long fade out. Okay, so what we do is we take that time value into the float. We'll go ahead and hide that value. We don't need it. And this, we're going to go ahead and rename this. Let's call this custom curve. Okay. And then what we're going to do is we're going to actually, we typically like these curve values to have output values between 0 and 1. That way we can take that into a multiplier float and just call this, and then we can multiply this value of 0 to 1 by whatever we want. So this is kind of an easy way for us to manage the maximum value coming out of here. And when we build this kind of this modular selection, these three here are going to be our graph operator. We don't really want to have to come in and modify the maximum curve value all the time, although that's fine, you can do that. But in our case, we're going to go ahead and modify this curve to actually only be within 0 and 1. It's going to take a little bit of tweaking because these values are so big right now. Let's do this, pull this down, and shape it out again a little bit more like this. So we get a fade in. And actually, let's go ahead and make it a little interesting. Let's have it drop down, and then make another key where it gets a little bit more velocity again, and then fades out. Okay, so very much a custom curve, and you can see here the maximum value that we're going to reach is 1. Okay, so boy, that's slow. Okay, so the particle age comes in. This value to time is going to interpolate that age. It's going to be somewhere between 0 and 30. And so as that age changes, because this is being updated every sample, however old the particle is, this value to time is going to be spitting out a new value, a new time value between 0 and 100 based on that value input. That time value then comes into this custom curve, and this custom curve then acts as kind of a custom lookup. And it says, okay, well, at 0, my curve value is whatever. At 10, my curve value is this. At 20, it's this. And so for each sample of the age coming in, or the time, we're going to go ahead and be able to access kind of a different curve value. It's kind of a bad explanation, but I'm hoping you understand. If you don't, email me and I'll try to do a little better. Okay, so then we take that value that's generated and looked up, and we take that value and we're going to go ahead and multiply it by some factor, and then we can go ahead and feed that into speed. Okay, so now and it's obviously a little too much. Let's go ahead and change that down to 100 and say this is a nice way where we don't actually have to come back in and reshape our curve. We can just say, okay, well, let's just drop it down by a major amount. It's a little hard to see because it happens so fast, but these particles, especially this first particle, you know, it starts off, it follows that curve, it gets some velocity, slows down, gets a little bit more, and stops. And so what's happening here is very much similar to what we had with the particle age being looked up directly with the velocity's time and accessing that keyframe at whatever time we specify. But in this example, we're able to just take that particle's age, feed it here into a value at a time, and then use that interpolated lookup of the age, get the time value, look at the time value here in the custom curve, figure out where on the curve it is, and then go ahead and we spit out that curve value, multiply it by this, and then we can control the speed. Now it might seem like a much more complicated pain, but this is really a much nicer way to be dealing with things in kind of a modular fashion. So what we'll do is we'll go ahead and save this kind of collection there. Actually, before we save it out, let's take a look at how we can make the system just a little bit better. These particles coming out here, they all have a lifespan of 30, and we really want to modify that so that we can make our lookup here much more generic. We don't want the value at a time to require the value coming in to be between a minimum age and a maximum age. We really just want it to be ideally a value between 0 to 1, or 0 to 100%. And the way that we can do that is we can do a little bit of math here. Where is my add multiply? And first what we'll do is we'll go ahead and we're going to set a particle data for these particles, and we're going to set their lifespan to be random. And this way each particle is going to have kind of a random lifespan. It's not just going to always be 30. It could be, say, anywhere from 20 to 60. And we can leave it at per call because this is only evaluated when the particle is born. Okay, so every particle who comes out of here, each one of these, is going to generate a random number between 20 and 60, and then it's going to put that value and set that as its lifespan. And so what we'll see, let's go ahead and get rid of that for a second. What we'll see is that the particles now, some of them live much longer. Okay. And what we're going to do is we're going to go ahead and generate a value of 0 to 1 based on particle lifespan. The way that we can do that is here with add multiply. We'll just expose the lifespan and also the age. And we know that if we take a particle's age and divide it by lifespan, that's going to equal a value from 0 to 1. So it's going to be A divided by B. So our age in value A divided by our lifespan, it's going to show us some lifespan progress of 0 toward 1. Okay, and then what we're going to do is we're going to tell our value to time. I just want to evaluate between 0 and 1. And what I'm going to be evaluating is that age to lifespan ratio. And so now, and actually, let's modify this curve so we can see it a little bit better, because this custom curve is going to be a little confusing for this. So let's delete these. Let's go ahead and just make it real nice and easy right in the middle. Set these out a little bit. Okay, so that, go ahead and make that 1. Wow, that's slow. Okay, so here we can see now these particles, based on their lifespan, they're going to perform this lookup. And fortunately now with the TP script operator, we don't actually have to calculate this add multiply age over lifespan all the time. We've gone ahead and built a very nice little scripted helper under the M3D category called life progress. Basically just takes a particle input and it's going to output a scalar between 0 and 1. It just does this whole calculation for us. So Same result. We're going to go ahead and delete that just in case you don't have that operator if you load this file. Okay, and so normally what we would do is we would go ahead and save this selection here and save this as, say, a graph operator. We already have one here under black boxes, M3D helpers, or actually M3D basic because we use it all the time. And we've got a GraphOp, basically does the same thing. It interpolates incoming values between 0 and 1, and then it's going to go ahead and feed those time lookups out to some of these curves. These are two different curves, a fade in and a fade out, which are connected to multipliers, so we can go ahead and use them right away. So just a simple little kind of graph operator black box. Okay, so this is just kind of one simple look at using animated values inside thinking particles. There's quite a bit else with timers and time base. We're going to cover that in another chapter. So let's go ahead and move on.